So take a look. That's that sandstone. So just use the magnifying glass, and the large one, of course, is a less magnification than the small one. So look in there and see if you can, use the small one and see if you can see those grains.
This is fascinating. I love rocks.
You're a rock star.
Yeah, I see him.
You see them? So what we're going to learn next is how this gets formed. And this can tell you a lot, like a whole lot, about the depositional environment.
How?
Well, so like we talked about the sizes, right? And if you think about it, which one of these is going to take the most energy to move around? Like which one's the heaviest? The boulder, right? Because it's the biggest. Which one's the lightest? Clay, because it's the smallest, right? So based on that, we know that we have to have an environment that has much more energy in it if we find boulders. Because if it has enough energy to leave a boulder, then it'll take all the clay away. So like what's an environment that has a really high energy? Rainforest. That's silly. A rainforest. So think about, a beach is a great environment, right? So a beach is an area where we see sand, so sandstone. But think of rivers, right? So we said that all of this stuff gets moved by rivers and water. So what's an environment, a river environment that has a lot of energy? You ever been whitewater rafting?
Mm-hmm.
Have you been whitewater rafting? No, it's great. And so when you're going, you see all these rapids around you, so it's got a lot of energy. Have you ever canoed on a lake? Mm-hmm. Okay, so if you're on a lake, you see that there's hardly any waves around. So that's going to be the depositional environments that we see between the conglomerate, where we have these really large grain sizes, so we have a high energy, and then a shale, we have these very small grain sizes. So all of that material gets rushed down the river into the lake, and then it's very, very still. You ever step out into a lake and you sink like down to here in sediment and mud? It's always fun to do. And that is why that's there, because it's very still, so all of the material can settle down in the water column.